Hey, I'd like to walk you through something that's changing the way we handle Kubernetes costs in the cloud. The Cast AI Cost Monitoring Suite isn't just another tool. It will become the central dashboard and guidance system for your automated cost optimization journey. The suite will help you make sense of your ongoing cluster expenses, help you attribute costs to individual teams, and will highlight savings achieved through the Cast AI cost optimization journey. You'll also find your next optimization opportunities in our detailed reports and analysis. What sets Cast AI's cost monitoring suite apart is how it aggregates all of your Kubernetes cluster expenses in a single dashboard. It's not just about the numbers, it's about understanding them. You can dissect these costs by workloads, namespaces, and individual teams. You'll finally grasp the efficiency of your resources and track how Kubernetes expenses shift over time. This level of insight is game-changing, and I'm going to explain why. This is what makes our approach unique. We are challenging conventional wisdom and bringing a fresh perspective on managing cloud costs. Starting with Cast AI's cost monitoring suite is easy. As soon as you connect your cluster to Cast AI, our reporting tool lights up in your console, ready to serve you rich, actionable insights. We'll dive into the specifics of connecting your cluster in a separate tutorial. As a starting point, here are some of the ideas that will be conveyed to you through our visualizations. The current optimization state of your Kubernetes cluster and the savings potential with Cast AI. Detailed insights into your daily and monthly cluster spend and its efficiency. Insights into your most resource-hungry workloads, including compute and network costs. And this is just the beginning of the journey. Choosing Cast AI for Kubernetes cost reporting and monitoring is a no-brainer. Why? Because it's completely free for an unlimited number of clusters, and it's available right off the bat when you install our read-only agent. The moment you connect your cluster, you unlock immediate insights into your costs and a deep dive into the efficiency of your Kubernetes setup. You get endless access to historical data, enabling you to analyze trends and make predictions without spending a dime. But of course, we don't stop at reporting. The Cast AI Cost Monitoring Suite acts as a baseline to understand where you started and how automated optimization is improving your Kubernetes bottom line every single day. It's important to visualize your progress through the optimization journey. As a result, our dashboard will become your source of truth.
In this video, we'll look deeper into Cast AI's Workloads report. This report is designed to help you understand your Kubernetes workloads compute costs and attribute costs to the relevant application owners. To analyze the workloads report, effectively follow these steps. Identify the workloads with the highest compute costs, most significant waste, or lowest efficiency. This will help you focus your optimization efforts on the workloads with most savings potential and to identify teams or cost centers they belong to. Compare the costs and efficiency of different workloads. This can help you identify patterns and trends in the overall usage of your cluster. Track the changes in the costs and efficiency of workloads over time. This can help you identify the impact of changes you make to your workloads and cluster configuration. The workloads report is divided into 3 main sections. I'll talk about each of them in the separate videos. In this video, we'll have a look at the compute cost report, where you can find a list of workloads with cost details per selected period. At the top of the report, you will see the 5 most expensive workloads. This section provides a breakdown of compute costs for each workload in your cluster. You can select a specific period to view the cost for that timeframe and filter workloads by the name, type, labels, or namespaces. To see the total cost of multiple workloads, select the relevant ones by ticking the box on the left side of the table. Another way of selecting multiple workloads is via labels or namespaces dropdown. You'll get the summary of total cost data for the group of workloads at the bottom. We can now dive deeper into individual workload cost details with daily history. This report provides cost details and the history of single workload within the selected period. It shows the total spend, current month forecast, average daily cost, and average daily cost per resource, CPU and RAM. You can use this data to identify trends and patterns in the workload's usage in terms of the number of pods per workload every hour and its cost. You can also see the daily compute spend per capacity type and a daily cost history table with average pod count, cost per pod, amount of requested resources, cost per resource, and the total cost. Welcome back. Let's now take a look at the efficiency report, where you will be able to see a list of workloads with efficiency details. This report shows the efficiency of each workload comparing requested compute resources to CastAI recommended right-sized values. This allows you to identify workloads that are given more resources than they need and optimize them for efficiency. To calculate the number of wasted CPU and memory resources, workloads used resources are subtracted from the total number of requested resources. The metric we used here is resource hours, which corresponds to the resource multiplied by hours of usage. For example, a workload that runs for 48 hours during the selected period with request set to 2 CPUs has a total of 96 CPU hours requested. Its average CPU usage, on the other hand, is 0.5 CPU during those 48 hours. Therefore, its actual total usage is 24 CPU hours, meaning that 72 CPU hours were wasted. Here, you can also zoom into individual workload efficiency details with daily history. You can use this data to track the changes in the workload's efficiency over time. Workload efficiency report provides current efficiency details per container inside the pod. In the report, you can see resource request, usage, right-sizing recommendation, and computed overall efficiency. Computed efficiency is calculated by comparing resource requests against the recommended right-sized resource values with more weight given to CPU, as this is more expensive resource. To provide right-sizing recommendations, the cost module evaluates the resource consumption of a container over the period of last 5 days and calculates the percentile value, where 95th percentile for CPU and 99th percentile for memory. These values allow application owner to adjust workload requests by copying and pasting the patch command or manually adjusting requests on manifest in the code repository. For more precise workload requests recommendations and to automatically apply them in real time, look into workload optimization video. Welcome to our video on workload network cost with CastAI. Today we will navigate through the key sections of the report to help you understand and manage your network cost efficiently. Let's take a look at the overview of the network cost feature, explaining its purpose and the basics of how it works. CastAI utilizes the egressd daemon set to identify in-cluster traffic. You can easily install egressd in your cluster by following the instructions provided on the Network Cost tab. Once installed, egressd collects traffic data and sends it to CastAI for analysis. From this data, CastAI automatically determines the appropriate pricing based on your cloud provider and gives you comprehensive visibility into your overall traffic patterns, including detailed information about interzone or intrazone traffic with the amount of transferred data and its corresponding price. This allows you to see the workload that caused the highest traffic within your cluster. In the workload network cost, you can analyze the destination of the workload communication and review the corresponding workloads. To see more, click on the View Details, and the Details drawer will appear, where you will be able to see all the destination information, traffic data, and cost of these data. Let's move on to the Workload Details page, where you can review the top 5 destinations that your selected workload is communicating with. To see more information about the traffic, costs, and other destinations, click on the arrow next to CrossAZ Communication widget. This will show you a drawer with full details. Cluster efficiency is available as part of the Cost Monitoring Suite. It provides helpful information on provision versus requested resources in your cluster, letting you assess node autoscaling and bin packing efficiency and plan action to reduce over-provisioning. The report delivers insights in your cluster CPU and memory utilization and helps you to put a number on over-provisioning during the current or past period. Over-provisioning refers to how many provisioned resources that do not end up being requested by applications you could reduce. CastAI calculates over-provisioning as the percentage difference between requested and provisioned resources. For instance, if applications in your cluster request 70 CPUs out of 100 provisioned across all nodes, this results in 30% over-provisioning. The data in the report, as with others, is derived from snapshots received every 15 seconds, ensuring near real-time accuracy. The top section of the report shows real-time insights of your over-provisioned resources. You can also see exact numbers on your cluster's provisioned and requested resources, as well as the average hourly cost per provisioned versus requested CPU and memory. Some users prefer to compare the hourly rates. At the top right corner, the average hourly cost per resource, CPU or memory, illustrates the expense of provisioned versus requested resources. The more the figures align, the lower the over-provisioning rate. Beneath the dashboard, you will find the detailed information about over-provisioned resources. This section allows you to filter resources by resource offering, spot, on demand, or fallback. Additionally, you can select preferred cost rate, choosing from hourly, daily, or monthly options. Lastly, the report includes a table at the bottom providing key daily efficiency details. This table is invaluable for monitoring changes in over-provisioning levels over time, and is particularly useful for comparing metrics before and after implementation of CastAI automation. For each day, within the selected time period, users can view the number of provisioned and requested CPU or memory resources. Detailed information about the capacity type becomes available when hovered over. Additionally, CastAI calculates the normalized cost for each provisioned or requested resource. Lastly, based on the day's provisioned and requested resources, an over-provisioning percentage is calculated. Generally, the over-provisioning percentage is expected to decrease following the configuration of CastAI. In stagnant conditions, CastAI effectively maintains low levels of over-provisioning automatically, thereby eliminating the need for manual intervention.